Hi everyone, welcome to the new session on projection of solids, that is session 3. We continue with projection of pyramids. Now, the problem 6 says a square pyramid of base size 35 and height 60 has one of its slant edges on HP. Draw projections of this square pyramid when the slant edge on which it is when the slant edge which is on HP is inclined at 45 degrees to VP. Assume base is nearer to the observer. This is the problem given. Now, as usual, we start doing this way. Now, draw the square pyramid in the top view like this. A, B, C, D, 4 edges, OA, OB, OC, OD, another 4 edges, totally making 8 edges. Square pyramid, base sides will be 35 mm. And write the corresponding front view with height as 60. And as you see here, A dash is this, front corner is B, we are looking from here, B dash bracket D dash, and this is C dash. Apex point is O dash. Now you have 4 edges here, 1 edge here, 1 edge here, totally 6, plus 2 here. OB and OD are merging, OB as the front edge. Now as you see in this problem, it is completely tilted such that the square pyramid is resting on slant edge O dash C dash on HP. You can clearly see this front view and this front view remain same. What you do is you copy, move and copy and rotate in such a way that O dash C dash is on XY line, and O dash C dash, since it is a slant edge, it is clear that slant edge is on HP. Okay, once you know this, you take the projectors down. You are expected to write one top view for this position. Now, as usual, you get all the points. This is C. On this line, you should find D and B. On this line, you should find A. Once you have all the points obtained, join the outer boundary of these points. As you are aware, in this problem, when you are looking from the top, base is nearer to the observer, base is exposed. Hence, what you do is, after outer boundary, as a second step, since base is exposed, base will be darkened. As a result, now you have 4 plus 2, 6 edges. You are looking from the top. In the third step, you have to complete 2 more edges. 6 edges are already over. 2 more edges are, one is AO, and another is CO. Since AO is nearer, we darken AO. And since CO is far away, we make CO dark dotted. Now as you see here, since AO is nearer, I'll darken AO. But CO, though it is invisible, you can show invisibility only up to A. Beyond that, it is invisible, merged with AO. And now you can see that CO is totally invisible, but that invisibly dark dotted is shown only between C and A. It continues till the apex. Now, axis is O to O1, that has also been shown. Now the problem says the slant edge which is on HP is inclined at 45 degrees to VP. Now as you know here, the slant edge which is on HP is in true length in the top view. This OC, what you have, is in true length, actual length. Okay, this is in true length. That is why when there is a slant edge which is on HP is inclined at 45 degrees means, since it is true length only, we don't have to undergo beta construction. Directly this one, tilt it, that is move, copy and rotate such that OC, not top view of the axis, it is OC slant edge which is inclined at 45 degrees to VP. Now once you do this, take all the points to the front. take all the points to the front. As you see here, O is here, O dash is here, C dash is here, B and D should be on this line, A should be on this line. You get all the points. As usual, the first step is always the outer boundary. Outer boundary, we do it dark. That is using 0.5 mm thickness line. Outer boundary has to be dark and it will be seen by the observer. Then you see, when you are looking from here, base is nearer than the apex. Hence, base edges are darkened. That means base can be seen by the observer. That is why what you do immediately is you darken the base. Now you count the number of edges, 4 plus 4 of the base, 1 O dash C dash, 1 O dash C dash, totally amounting to 6 edges we are done. We have to complete 8 edges totally. You are left with O dash B dash and O dash D dash. Since B is the nearest corner, OB is the nearest edge, this has to be seen by the observer. Hence O dash B dash we darken it. And since OD is far away edge, for an observer who is looking from the front, back edge cannot be seen. Hence we make it dark dotted. That is, front edge O dash B dash is darkened, O dash D dash we make it dark dotted. Hence we complete, and finally we'll show the axis also. This completes problem number 6, projection of square pyramid, where the square pyramid has slant edge on HP which is inclined at 45 degrees to VP. In this complex position, how it is seen in the front view, how it is seen in the top view, we have drawn here. Always you should know, first stage front view will be same as second stage front view because it is moved parallel to VP, and second stage top view will be same as third stage top view because the inclination will not be changed with respect to HP. Now we move on to problem number 7. In this problem number 7, a square pyramid of base size 35 and height 60 is hung on one of its corners of the base with top of the axis inclined at 45 degrees to VP. Draw projections of this pyramid in this position, assuming apex to be nearer to the observer. Now in this problem, you start like this only. Draw the square pyramid. In the top you draw A, B, C, D, OA, OB, OC, OD, O1 is the axis, 35 is the side. Take the front view. This is A dash. Front, when you are looking from here, B can be seen, D cannot be seen, B dash bracket D dash, C dash, and height is 60, O dash apex is at 60. Join all this. Now we are here, you have 4 edges, 1 edge here, 1 edge here, and 2 merged edges here, OB and OD. OB and OD are merging. OB is the front edge, OD is the back edge. Now, as I've said, this is a solid. Solid means, for a pyramid, the center of gravity is located 15 mm from the base. 15 mm from the base. That means 60 means 1/4 of 60. That is, it is 1/4 of its height will be the center of gravity. That's why we locate G dash at a distance of 15 mm. Okay, once you do this, the idea here is once you get the G dash, if you imagine a plane here, the weight below G dash will be equal to the weight above G dash. That the total weight here above G dash, if you imagine a horizontal plane here, above G dash will be equal to the weight below G dash. That's why whenever in a pyramid, if you want to locate the center of gravity, it has to be 1/4 of the total height. In that way, get G dash and then make C dash G dash one imaginary line. Now, it is a suspension problem. What you do is, we tie a thread to the corner, C dash, and if you hang it in the space, as per the property of the solid, the line connecting the corner and the center of gravity will be perpendicular to HP. In that way, when you do this, you can clearly observe you can clearly observe this way. That means you are tying a thread to this corner and hang it in the space. If you imagine, if you hang it in the space, nowadays it is hung in the space, and the line connecting the corner and the center of gravity is perpendicular to XY line or HP. That means you cut, that is move, copy and rotate in such a way that C dash G dash is perpendicular to XY line. This you do it in the second stage. This is a new problem, very important from the examination point of view, where suspension problems you should know about G dash, how to locate G dash, and in the second stage front you assume a thread is tied to one of the corners, either A dash or C dash, and if you hang it in the space, entire solid, the line connecting the corner and the center of gravity will be perpendicular to HP or XY line. Now it is this way. Now it is hanging in the space, and it is hung on at a corner C dash. Now in this position, once you make it to this position, the procedure remains same. Get all the points in the other view, and the next step is join the outer boundary of these points as usual. First step is over. Second step, compare apex with the base. When you are looking from here, base is nearer, immediately darken the base. Now 4 plus 2, 6 edges over. You are left with only 2 more edges, OC and OD, OC and OA. Since OC is nearer, darken OC. OA is invisible, you make OA invisible, dark dotted, but dark dotted can be shown only between C and A, because up to OC, that OA is, that is the invisible edge is merged up to OC, and you show invisible edge, that is dark dotted, only between C and A. Show the axis also. Now in the third stage, what they say is, the top view of the axis is inclined at 45 degrees to VP. That means, that is move and copy, rotate in such a way that the top view of the axis is inclined at 45 degrees to VP. Then once you do this, same way, once you get the third stage top view, copy and paste and rotate, get all the points in the other view, join the outer boundary of these points. Since apex is nearer than the base, remaining edges should be made dark dotted, invisible. In that way, I have made the remaining edges of the base invisible, since apex is nearer than the base. Totally 6 edges are over. You are left with O dash B dash and O dash D dash. O dash B dash, since it is nearer, is darkened. O dash D dash, since it is away, it is made dark dotted. In that way, 8 edges are completed, and finally show the axis. This completes the problem number 7, which is a problem of hanging. Okay, now the problem is clear here. It is a square pyramid of sides 35 and height 60 is hung on one of its corners, say C, such that the top view of the axis is inclined at 45 degrees to VP. For this, we have written one front view and top view in this position.